All right, ladies and gentlemen, we're still talking about the idea of polynomials, how to add and subtract, and this time we're going to focus on the idea of subtracting. If you think back to how we have always added or subtracted, when we're talking about groups, we got to remember when we're subtracting, it's actually got to be an addition problem. That's really how we should be looking at all things, is how do I make it addition? Because addition is simple, it's straightforward. If I have a positive and a negative, they can combine, no big deal. But how do you subtract a negative? Things like that. It starts throwing curveballs at us. We don't want to have to think about it. So let's get it done early. What I mean by that is, if we're subtracting two groups, so here's a subtraction sign. Group 1 is on the left, group 2 on the right. If we're subtracting two groups, what that means is to get rid of that subtraction and turn it into addition. That means all I want to do is distribute the negative sign as if it was saying the opposite of each term. So here, that means that the minus a negative 2n squared term is actually the opposite of negative 2n, which is positive 2n, which I have written here and it's highlighted in green, but I'm going to add an orange highlight just for a second. That is positive 2n squared because I distributed this negative sign and that term to the negative 2n. All right, moving on from there. I've already done all the drawing. If you have any questions, make sure you ask about it in class. But that is how you distribute the negative sign. Each term you read as the opposite. So this is actually read as the opposite of negative 2n plus the opposite of positive 2n plus the opposite of negative 4. And that's how you read any subtraction problem as an addition problem. Now, when I do all of those changes, I get what's in orange down here. Clicked on it, but apparently it didn't work. There we go. All of the second line there is what came from distributing that negative. So now I just have to work it. Now I have 4n squareds and 2n squareds. That means I have 6n squareds. Then I also have 0 n's, because notice up here there weren't any listed. So this plus 0n, that term came specifically because I did have an n over here, so I needed one on the left. Well, 0 times anything is 0, 0 plus anything is itself, so I can write 0n. When I did that, I get 0 n's, I had none, but then I gave away 2. That means right now I owe 2 n's. And then I have 5 and I get 4. So overall, that means I have 9. So if I was going to write this all together in standard form for a polynomial, this 6n squared minus 2n plus 9 would be my answer. All right, so let's look at the next example. I've already distributed the negative again, and I've gotten the terms on my second line that are written in orange. So I can go to the next step and I can say, well, I had 4x squareds here, and I gave away 3x squareds. So that means I have 1x squared left. Now that one's just a placeholder. I'm going to get rid of it later, but I'm reminding myself I do actually have one, because 4 minus 3 is 1. Now here I have 3 x's and I got another x, so that means I have 4 x's, and they all live in Texas. Now here I have 5, I get 8, that means I now have 13. Now if I'm going to rewrite this, which I should, I'm not going to rewrite that one like I mentioned before. I'm just going to have x squared plus 4x plus 13. And I now have the standard form of the polynomial when I add those two together to be x squared plus 4x plus 13.